Hey everybody, this is the video for geometric series. In the last video we talked about arithmetic series. They're pretty similar. I'm going to make this as simple as I possibly can, so stick with me here. We've got a different formula that we're using for the sum versus arithmetic series. So we need a first term, and then we've got 1 minus r, which is our common ratio, to the nth power over 1 minus r. So I'll show you how to use that. Also keep in mind here, it does say find the sum of the geometric series, but make sure you recognize how to identify that it's geometric. You can see that multiplication is happening between our terms. So like 3 times 3 is 9, 9 times 3 is 27, and so on. So that gives it away that it's geometric. So it says find the sum. So to find the sum, we need to use our new formula for sum. So that is the first term times 1 minus r to the nth power over 1 minus r. Okay, so the things that we need a first term to plug in. We need our common ratio, like the what's happening each time, and an n, how many terms are there? Okay, well our first term is 3, I can see that. Okay, for our ratio, what's happening? Well, we're multiplying by 3 each time. So 3. Now 3 is our first term, 9 is our second term, 27 is our third term, but what is 2,187? So what I like to do is fill in those dots, right? So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3 is 729, times 3 is 2,187. So we've got 1, 2, 3, 4, 5, 6, 7 terms here. So that's our 7th term. So that means n is 7. So we now have everything we need to plug in. So we've got our first term, which is 3, times 1 minus 3 to the nth power all over 1 minus 3. So I just plug them in. Now, you want to be careful with the calculator. I kind of like to break things up a little bit. If you've been in my class or watched my videos, you kind of know that's my style a little bit, to just break things up. I get a little nervous. So I just did what's inside the parentheses. So that was 3, and then that would be 1,093. So then let's multiply them. So that gives me 3,279. Also, if you would have just added all these together, all these numbers, 3 plus 9 plus 27, that would give you 3,279. So you could always check that way too. All right, so I'm gonna get rid of that so I have room for the next problem. So we need to find the sum. Same idea, we have the same sum formula. We want to find our first term, and then 1 minus r to the n power over 1 minus r. So we need a first term, common ratio, and how many terms there are. So our first term is 16. The common ratio, so that's like what's happening each time. So you want to be careful. I think a lot of us right away would be like, oh, it's dividing by 2. Yes, it technically is dividing by 2, but with geometric, we always say it in terms of multiplication, so that would be times a half. So just like a little note here, times 1/2 is the same thing as divided by 2. Times a third is the same thing as divided by 3. So you just flip it. It's not a big deal. Okay. So we know that that's a half, or we could write 0.5. That might make it easier when we're down here using a 0.5 instead of a half. And then how many terms are there? So we know that 16 is our first term, our second term, our third term, but what's 1/8? So let's find out. Okay, so we've got 16, 8 plus 4, okay, times a half would be 2, times a half would be 1, times a half is 1/2, times a half is 1/4, times a half 1/8. All right, so that's 1, 2, 3, 4, 5, 6, 7, 8 terms. All right, so now we have everything we need to go ahead and plug in. So the sum of our 8 terms is equal to the first term, which was 16, times 1 minus, I'm going to put 0.5 to the 8th power over 1 minus 0.5. So again, be careful with your calculator. 1 minus 0.5 to the 8th power. Oops. So you've got to be careful. Even I make mistakes here. Okay, and then divided by 1 minus 0.5. Okay, so that's what's inside the parentheses. Now I'm not going to write that down. That's a lot of writing. I'm just going to write times 16. And yours will probably show it as a decimal if you're following along. So that would be 31.875 is the sum. Okay, nice job. So let's go ahead and let's look at our summation notation or sigma notation on the next page. So very similar to what we learned with arithmetic, but it's different. It's we're looking at geometric series now. So if you notice here, we've got our n up top, just like we did before. Our index, but this time it's our first term, and then we have our r to the n minus 1. So let's just look at an example because we're still using our sum formula just like we were. But yeah, let's just look at an example. So it says find the sum of the geometric series. So a couple things. Trying to think here. You know, I think sometimes the best thing you could do is think about what it is that you need. So like I know I'm going to be using this formula here, right? And what I'm going to need is I need a first term, I need an r, and I need an n. And what's really nice about this is everything is right there. So if you look up here and like see what you've got, like we have all of our different pieces, right? So like our first term is 3, it's right there. Our r is right there, that's 4. And then the n is the top one, that's 13. So what's kind of nice is we have everything we need. So I can just go ahead and plug in. We've got 3 times 1 minus 4 to the 13th power over 1 minus 4. So again, be kind of careful. Power divided by, oh, I think I did that. No, we're fine. Divided by 1 minus 4 and then times 3. Ooh, that's a huge number. My goodness. So that's going to end up being 67,108,863. Nice. Okay, let's do one more like this just so you can make sure that we get it and see enough examples here. And again, you're always welcome to pause and give it a try. And let me get rid of this from our notes just so it's not in your way while I'm teaching it here. Okay, so we're going to find the sum. So kind of think to yourself, okay, what's the first thing we do? Or at least what is it that I like to do? I like to write down what it is that we're going to need, just because at least that gives you a starting point. When you're looking here, it's like, okay, well, you know you need a first term, you need an r, and we need an n. So your first term is right there, r is there, and n is there. So we've got a 7, -5, and 11. Okay, so when we plug everything in here, I think where students sometimes get tricked here too is also like there's a -5, so we want to be careful. And then same with down here. Just want to be careful with all of those negatives. So let's go ahead and try typing them in. So I've got 1 minus a -5 to the 11th power divided by, and then you know that this is going to become a plus, so I guess I could just make it a plus with the way that it is. So 1 plus 5. And then that's what's in the parentheses, so now we have to times 7. So another large number here, we've got 56,966,147. Okay, so before we end here, I am going to do a word problem with you, just since we haven't done a word problem with this chapter yet. So this says, Mr. Anderson worked at a golf course during the summers he was in school. He started in the 7th grade making $6.25 an hour. He worked an average of 500 hours each summer through the 12th grade. He got an 11% raise each summer for 6 years. How much money did he make over the course of his time at the golf course? Before taxes, of course. So let's think about that really quick. You know that we're talking about geometric series. So I'm going to write down what it is that we need. So we need our first term. We need an N, and we also need an R. So the first term, well, it's not technically 625. We want to figure out how much money he made. So let's figure out how much money he made that first summer if he worked 500 hours. So that would be about $3,125 that he made that first summer. Okay, we're talking about 6 years, so that's how many terms or summers we have. And because he got an 11% raise, the way we write that is 1 plus 0.11, so it'd be 1.11. So that's how we increase by a percent. Okay, so now we have everything we need. So the first term was 3,125 times 1 minus 1.11 to the 6th power over 1 minus 1.11. So we probably want to type that in our calculator. So 1 minus 1.11 to the 6th power divided by 1 minus 1.11 times 3,125. Ooh, so that's about, he made about $24,727 and let's say 69 cents in those summers. It's not bad for, come on, magnifying glass. Sorry, here. There we go. Sorry, I needed to fix that. There we go. That's about how much money he made in those summers. And, you know, for the next section, we just have one example. So let's go ahead and just do that one really quick. This is finding sums of an infinite geometric series, so a partial sum, and we're going to talk about, it's just one extra formula. So I'm just going to do one example here. So we have a new formula. The sum is equal to the first term times 1 minus r. And the difference here, or something that's kind of happening, is the absolute value of r is, why would that be less than 1? So just so you know, the common ratio is between 0 and 1. Okay, so let me erase this here so we can do this one really quick. And it didn't erase, come on. There we go. Okay, so finding the sum here. So let's think about what it is that we want. Notice something different. Because this is an infinite geometric series, it's going to have the infinity. So there really isn't an n this time around because it's infinite, right? There's not a finite set of numbers like there was before. So our formula is equal to the first term over 1 minus r. Okay, and just so you know, like n, that's not happening for this one, right? It's just infinity. So our first term, we've got right here. We have our r, it's between 0 and 1, and it looks like we have everything that we need. So the sum is equal to the first term, 6 over 1 minus 0.6. So that would be 6 divided by 0.4, and your calculator, that would give you 15. So that's how you do that problem, and that's kind of like the one you guys will see on your test too. Okay? All right, I'm actually done this time. Thanks for bearing with me. In this video, we talked about infinite geometric series, and then we talked about just regular geometric series. If you would like to, I'll give you a chance to pause on this screen here. I've shown this to students in the past. This is just kind of like a note screen here of all of the different pieces that we learned about arithmetic, geometric, and infinite geometric series. So I've got examples here, like just kind of putting everything together. So here's 2 for arithmetic, here's 2 for geometric, and here's the 1 for infinite. If you would like to write this down or come back to the screen, it's kind of helpful seeing them all together and the differences, especially with like the different formulas and kind of what to do. All right, I hope this was helpful, and thanks for watching.